This slide shows a timeline from January 1st, 2020 through the end of April of the same year. A point on a timeline, shown here as March 20th at 4:55 p.m, is called an instant in time. You can usually think of an instant as an event. For example, maybe your child was born on this day and at that exact time. An interval or span of time on a date timeline is called a period. It's often represented by elapsed time in date units such as years, months or days. For example, the time between March 25th, 2020 and April 14th, 2020 was a period of 20 days. This slide shows a timeline for a single 24-hour day. This timeline can have an instant as well, as shown at 16:30, which represents 4:30 p.m. on this timeline. Maybe this is the time you get off work. Again, it's a singular event on some timeline. This slide is also showing a span of time from 6:40 a.m. until 1:20 p.m. When the interval is time-based, in terms of the units being in hours, minutes or seconds, this is called a duration. On this slide, the duration lasted 6 hours and 40 minutes. On the previous slide, I showed you that you can represent an event on a timeline as an instant. Java provides the instant class for this. It has two fields, one for seconds, a long, and one for nanoseconds, an int. If you're new to programming, you might be asking, what does seconds mean? How can you store a moment in time as seconds? Doesn't it need some context, like a starting point in time from which to measure these seconds or a defined timeline? The answer to that is yes, it definitely does. These seconds are called epoch seconds by Java's documentation, and the epoch is the starting point for many such points in time. Instead of having to specify this point in time, every time you want a timestamp or instant of time, many software languages use a specific date and time, called epoch time. Midnight UTC, Thursday the 1st of January 1970, is called alternately Unix time, POSIX time, epoch time, or Unix epoch time. Computer systems have different epoch times, but many software languages use this particular date and time, including Java, as the predetermined start of time. Obviously 1970 isn't the start of time. This date was an arbitrary date selected by Unix engineers to create meaningful timestamps that could be compared to each other. This date kind of stuck and is now a standard for a few operating systems as well as many programming languages. It's used to create timestamps whose meaning, as seconds, can be understood. You don't have to memorize this date, and you probably don't ever have to worry about it for most of your timing needs. If you ever do want to see it or use it, it's a constant named epoch on the local date and instant classes. UTC is a symbol that stands for Coordinated Universal Time, which coordinates with Greenwich Mean Time, GMT, for those of you that don't know. This will be important when we look at time zones, which I'll be covering very shortly. First, though, let's just quickly look at the duration and period classes. If you look at the duration class on this slide, you might think it looks like the instant class, but there are significant differences. First, duration and period do not implement temporal or temporal accessor. They instead implement temporal amount as shown. This means these classes are something quite different from a unit of date or time. They are amounts of time, or time counters if you like. Both represent elapsed time between units of time or dates. Maybe you'll remember from an old geography class that the Earth is drawn with imaginary lines on it to help uniformly describe locations on Earth. The lines drawn from the North Pole to the South Pole are called meridians. These could be drawn anywhere, but a prime meridian was historically agreed upon as a starting point or the zero measurement. This is a reference point for all other measurements. This is a little bit like the epoch time I talked about previously, because you have to start somewhere and pick a reference. This somewhere was Greenwich, a town within London County in England. Because time is also related to where you are on Earth, this meridian became the basis for describing a uniform time. The time in Greenwich was solar time, based on the position of the sun in the sky. When atomic clocks were introduced, they were able to provide more precise time than Greenwich Mean Time, GMT. In 1972, GMT was superseded by UTC, which stands for Coordinated Universal Time and is based on atomic time. The differences between GMT and UTC can differ by up to 0.9 seconds in a day. For this reason, GMT and UTC are often used interchangeably when you don't need great precision. A time zone consists of two parts, a UTC offset and optionally information about daylight savings time. Java derives its time zone data from three sources. The Internet Assigned Numbers Authority IANA's time zone database, TZDB, is the default and takes precedence over the others. IATA, the airline industry body, and Microsoft. Two helpful links are displayed on this slide. The first site gives you a list of the time zone identifiers. The second gives you a list of daylight savings rules. Both of these sites use the IANA time zone database as their source. I'll pull up the first link. I'm going to scroll down to Australia and pick Sydney. The time zone identifier is shown as Australia Sydney. This is the identifier you'll want to use in Java to set or retrieve a specific time zone. What I also want you to see here is the offset, plus 1100 and AEDT in parentheses. This is the offset and the daylight savings information for Sydney, Australia for November 13th, 2023. Note that the offset may change to plus 1000 depending on the date because of daylight savings. The offset includes a plus or minus sign, followed by 2 digits for the hours and 2 digits for the minutes. A plus sign means the offset is to the west of the prime meridian. A negative sign means the offset is to the east of the prime meridian. I'll go back to the previous page. And now pick America and New York as another example. Here you can see the offset is minus 0500. This means it's UTC minus 5 hours, whereas Sydney was UTC plus 11 hours. New York uses daylight savings time rules specified by the code EST. And again, note that the offset may be different depending on what time of year you run this, again due to daylight savings. I'll now pull up the second link from my slide. If I search for Australia, I'll see two entries in this table. Sydney is in New South Wales, so on the first Sunday in October, its UTC offset increases by 1 hour. The point of all this is not to scare you. These rules can be complex, but fortunately, the rules are built into Java's classes, which I'll be showing you shortly. It's just important for you to understand that the UTC offset will always be applied, but other local rules may also apply. There are classes in java.util that may look attractive to use and were used before JDK8. You'll probably run across these classes at some point in older code. These are date, time zone, and Gregorian calendar. Additional classes for formatting are in the java.text package, date format and simple date format. The use of these classes in new code is discouraged. The immutable thread-safe classes provided by the java.time packages should be used instead. I won't be covering these old classes in this course, except to point them out here, so you'll recognise them if you see them. Finally, I just want to talk about the two methods on the system class. System.currentTimeMillis returns the milliseconds since epoch time, so midnight, January 1st, 1970 UTC. This time is based on the operating system. This can be used to measure elapsed times or provide timestamps. System.nanotime uses the JVM's high-resolution time source to return nanoseconds from an arbitrary origin time, which is not epoch time and may even be a time in the future. This origin time may differ across different JVM instances. For this reason, this time can't be used to represent real time or wall clock time. It shouldn't be used as timestamps for data. Instead, its purpose is to measure elapsed time for invocations in a single JVM instance. Okay, I hope I haven't worn you out with too many slides here. These concepts will continue to be important when I get to localization and internationalization. In the next video, I'll be demonstrating going over creating instance, period and duration classes, as well as zone date time, so I'll see you in that video.